Awesome. So, hello everyone. We have a great in-person attendance today. Today it is a pleasure to have Mina with us to give a talk on designing and evaluating language models for human interaction. She's a PhD student at Stanford, advised by Professor Percy Lam. Her research focuses on language models' ability to interact with humans and their usefulness in augmenting human capabilities. I enjoyed her recent work called Evaluating Human Language Model Interaction. Great paper, you should take a look, which led to this invited talk actually. Her work on CoAuthor recently was also given an honorable mention for CHI 2022. So without further ado.
Yeah. Yeah, thanks everyone for coming. For those of you who are at the group meeting, my name is Mina Lee, and today is my great pleasure to talk to you about my research on designing and evaluating language models for human interaction. And I really want this talk to be interactive, so feel free to interrupt at any time, share your thoughts, ask questions. And so it's usually composed of 3 parts, but I cut the first part and then we'll focus on the evaluation part mostly for today, so that we can have more lively conversation. So, another thing is that I am trying a new flow here. So I will start by sharing 3 quotes to prime today's talk and discussion. So I'm really curious what you think about this. So the first quote is from this book called The Creativity Code. So it goes like, being creative requires a jolt to take us out of the well-carved paths we retrace each day. And machines might ultimately help us as humans behave less like machines. Okay. And the second quote is from the New Yorker article. And it says, the writer's job becomes as an editor almost. Your role starts to become deciding what's good and executing on your taste. Not as much the low-level work of pumping out word by word by word. Okay, last quote is from Katie. It's her article on Wired. And she says, while some writers are eager to get sentences on demand, others are hesitant to let an external entity, such as language models, choose their words. As several writers told me, once something is on the page, it's just a little bit harder to imagine anything else. So I'll come back to these quotes at the end of the talk. So let's get started. I think it goes without saying that we interact with language models every day, with or without even realizing it. So think about internet search, or writing an email, or editing your own text. You may notice that these systems are proactively predicting what you're going to type next or how you can improve your own text. And there are so many different ways to interact with language models. So this is a story writing tool called pseudo-write. And in this tool, one of the functionalities is to click on a word in your story, and then it shows multiple word clouds that you can explore, and then you can click more words in one cloud and it will show more words and so on. And of course there is a ChatGPT. So dialogue is another form of interacting with these language models. And just to get a sense of how many of you are using ChatGPT, raise your hand if you're using ChatGPT more than once or twice a week. It's all clustered in front. Okay, awesome. Yeah. So yeah, I think a lot of us are interacting with language models in one way or another. But in this talk, I'd like to draw your attention to our common practice these days. So I will argue that most language models these days are developed and evaluated non-interactively. And what does that mean? So let's take a look at story writing as an example. let's say we have an input story title, like the mage, the warrior, and the priest, and we have a language model. So what we do in a typical, training or inference setting is that we feed this input to the model and then have the model generate an output, which can be this kind of story, like race sweat the ground and blah, blah, blah. But as we saw earlier, language models are deployed to interact with humans. So instead of this illustration, what happens is this, where a human user queries the system, gets the output from the model and iterate over time, and eventually get an output. So let's look at the story writing example again. So we have the same input, and instead of having the model generate entire story, what might happen is that the user could start the story by saying once upon a time, and the user may query the system, and the system generates something like this. There was a great mage who lived in a tower. And the user might not like some part of it and then go back and change it and query again. And that becomes the output of this human language model interaction. So in this interactive setting, now the question is, how can we design and evaluate language models for human interaction? So there are three parts in this talk. First one is supporting human needs. So when writing, for example, when you're brainstorming, you might want new inspirations. Whereas if you're editing your text, you might care more about fluency or accuracy. So there are many different human needs, and language model out of box may not support like what you want the model to do. So I'll briefly touch over different ways to support human needs. And the second part is capturing the interaction. So once language model can do something the user wants, then we want to capture the interaction or the dynamics between the user and the model, and then use that to analyze language model's capabilities in interactive settings. And the third part is about evaluating interaction beyond writing. So I've been talking about mostly writing task and textual input and output, but language models can be used for a variety of tasks beyond writing. So we will look at 5 different tasks and think about a way to evaluate interaction in a more holistic way. So that would be the outline of today's talk. Is there any questions so far? No? Yes.
Well, quick question. Would you consider the like a RLHF-backed language model to be something that is outside the scope of this? That is something that is trained with human interaction as part of its objective?
So that is, yeah, I think that is the borderline, because yes, at training time, you do have humans, but then I feel like that's, I think still the evaluation is focused on like what the model is outputting. So although it is probably benefiting the human language model interaction, it is still not at the center of the focus. But yeah, we can talk more about that. All right, so first part, which I'll just briefly talk, this one slide is to support human needs. And all of you know that language models are like a lot of language models are trained to predict the next word. So when you have both like previous context and future context, like it only looks at the previous context. So the first work was about enabling these language models to fill in the blanks by looking at both previous and future context. And then I built a bunch of other writing support tools with awesome collaborators. So this one is about autocomplete systems based on the keywords. This one is about contextual thesaurus. So you can think about thesaurus.com, but it's based on the sentence where the word is in. So there are various ways that you can make language models more useful for humans, especially in the writing context. But today I'll mostly talk about evaluation. So the second part of the talk, which I'll dive in, is based on this paper called CoAuthor, Designing a Human AI Collaborative Writing Dataset for Exploring Language Model Capabilities. So recall that most language models are developed and evaluated non-interactively. What that means is that we take the output from the model and have a bunch of metrics to evaluate the quality of this output. So we might care about its similarity to a reference if you already have some notion of gold standard, or if you don't, then you might resort to human evaluation with third-party evaluators. But we want to understand language models' capabilities in interaction. So how can we do that? So let's take a look at the interaction between the user and language model more closely. And we're going to look at event by event. So first, the user writes text, like once upon a time. And then maybe the user doesn't have like plot idea in her head and asks the system to generate some suggestions. And the system might generate not just one, but maybe 5 or 10 different completions. And the user browses them and accepts the one that she likes. But then the user might go back, like move the cursor, edit some parts of this machine-generated text, move the cursor back to the end of the text, and then query again. But then this time the user didn't like any of the suggestions. So then the user might query again and again. And once she finds something that she likes, then like she accepts the suggestion and basically repeat the process. So what we do in this project is to take these interaction traces and define metrics on top of it and use this for analysis. And we argue that interaction traces can address questions about language models' collaborative capabilities. So the types of questions that one can ask are as follows. So first, can language models generate fluent text in response to user text? So in this case, you have a text that's like mixture of user written and machine written text, and that's different from what you will normally see in the data set or benchmark, or just the model's own like distribution that it learned from the internet text. And secondly, can language models contribute new ideas to users' stories? So in this case, maybe the model suggested that the mage lives in a tower, and the user might use that in the later part of the story. And lastly, what influences collaboration patterns the most? So collaboration patterns can be many different things, but the two patterns that we look at is like how evenly distributed the queries are. So like, do users query mostly during, like the first few minutes, or like evenly distributed throughout the writing session? And also usage, like do users use a lot of suggestions or like not that much? So to investigate those questions, we built an interface called CoAuthor, and it's pretty straightforward. It's a text editor initialized with a writing prompt. And the interaction, we allow users to press the tab key whenever they want, and it will give them 5 suggestions. And the users can browse these suggestions, discard all of them if they don't like, select one of them if they like, and then edit like if necessary, and they repeat this process. And to generate the suggestions, we used GPT-3, Da Vinci, with high and low randomness. So with low randomness, which was done by tuning like temperature value and presence penalty, you see that like all of these suggestions are kind of similar and talk about, like the same or almost same or similar ideas. Here it's like little hut or a little shed. Whereas if you cranked up the temperature, then like you get more diverse suggestions. So here you see more variety in the 5 suggestions generated. And with that, we collected over 1,000 writing sessions between 63 users and GPT-3. And here the users are crowd workers from AMT. And we looked at both creative and argumentative writing. And for each type of writing, we used 10 different prompts. And each session lasted about like 10, 11 minutes. So it's pretty short. And each like story and essay is about 400 words long. So yeah, this is an example of writing session in CoAuthor. Oh, yeah, I should mention that you can go to this website and then replay all of these writing sessions. So whenever user does something in the text editor, we recorded it along with timestamps so that like every session can be replayed precisely. So this is one example. I think it's maybe 3 times faster than the actual speed. But you can see that the user starts with the prompt and then queries the model and then selects one of the suggestions and then like continue writing the story, edits here and there. So yeah, that's the type of data we work with.
Do you know anything about the user profiles, like whether they would consider themselves to be creative writers? Is it truly random? Did you try to recruit people on like Turker Nation, or what's the provenance of the Turkers?
Yeah, we didn't collect demographics. Like the only thing we asked was like whether they're native English speakers or not, and 62 people out of 63 people were native English speakers. But other than that, we don't know their like gender, education, like background in creative writing, and so on. So it's possible that it's just kind of like all over the place, or it might be all kind of similar and they're all amateurs. Yeah.
So there's a broad collection approach rather than trying to target.
Yeah.
Was there a specific like qualification test before you onboarded them for the full task?
Yeah, good question. So yes, there was a qualification round where we basically wanted to see that people do their work. So 2 requirements we had was that 1, the story has a conclusion, because it's very possible if you keep taking the model suggestions, it will like you can write something plausible, but then it just never ends. So we wanted them to put some thoughts in, making sure the stories are coherent and interesting. That was one requirement. The other one was to use model suggestion at least once, like in the qualification round, so that we know that they are able to do that. But during the main study, we didn't ask them to, like use it if they don't want to. And then, I basically manually checked like people's stories. So 200 people participated in the qualification round, 100 people got qualified, and 63 people ended up writing stories and essays. All right, so with this, about 1,500 interaction traces, let's answer these 3 questions we had earlier. So the first question was about language capability. Can GPT-3 generate fluent text in response to user text? And here on the x-axis, I'm showing user. So these are sentences written by only the user and sentences written by GPT-3, and the sentences written by GPT-3 first and then edited by the user later on. And we see that for the number of spelling and grammar errors, it actually decreases. And when the user edits the machine-generated text, it actually has the fewest errors. And when it comes to the vocabulary diversity, the model-generated text has slightly less diverse vocabulary, but then like for the sentences that are written by both, we see the most diversity in terms of vocabulary in the text.
So these were all these sentences come from people using CoAuthor, so it's within one text, some sentences written by the user, some by GPT-3, some by both. Right?
Exactly.
And what's the breakdown in terms of percentages?
Oh, so I think it was about 70%. So 70% of text was written by the writers.
What about full sentences?
Oh, full sentences. Yeah, that number I don't have off the top of my head. So this is
close to balance.
yeah, maybe maybe we should have. Yeah, so this one I think is probably based on the character because we are really tracking like each character, the source of each character, because we have the full trace. So that number might represent the character level percentage. But yeah,
to get the bar graphs, you had to have the raw numbers, right, of the number of sentences to get this.
Right. Yeah, that might be in the paper, but yeah, I don't have that off the top of my head.
What counts as an error?
So here we're just using I think it's called language something, a Python library to detect just the spelling and grammar errors. So it's like really basic errors. Yeah. Yeah. Any other questions so far? Okay. Yeah. So it was quite promising to see that the sentences written by both a user and the model had the fewest errors and most diverse vocabularies. But it's possible that that might be because, yeah, those subset is smaller than the others. And secondly, we looked at models' ideation capability. And I'm curious if you have ideas for how we can design metrics for this. So we resorted to this pretty conservative and limited metric to identify new ideas. Which is to identify named entities in the model suggestions. So in this case, the model wrote, he also knows that she's been going to Dr. John, who is a specialist for her asthma, and Dr. John is a named entity. And you can systematically detect like the named entities, like new named entities in the model suggestions, and to see if they are reused in the subsequent part of the story. Then like you could kind of conservatively say that, okay, like this character or this location was suggested by the model and then reused. So maybe that's like contributing to the story in terms of ideation. And when we used that approach, we saw that 13% of suggestions contained new named entities in the creative story writing setting. And among those, 20% of the suggestions, 20% of the new named entities in these suggestions were reused by the users. So yeah, that's like one way to look at it. But yeah, I'm curious if you have any ideas to like detect like ideation contribution of these models, like something to think about.
You could check events. Basically, ideas are just events. Like, so you could see how many different events are related to a person, and then ideate based on that.
Mm-hmm.
Because all ideas are basically events which flow one after the other. Story.
If you look at, well, did you look at perplexity at all as a way of judging this?
No.
So I don't know if this would work, and there could be some adversarial approaches that get around this, I guess. Like mildly adversarial model, but if you have the model, in this case, the blue is GPT-3.
Yeah.
Right. So if you look at the perplexity of the text before the suggestion, and then the perplexity of the text after the suggestion, and if it's higher, then versus like you'd have to aggregate over multiple cases over like a roughly same span of text where there wasn't an idea, or possibly like, yeah, I guess where there wasn't an idea. So it's like presumably the they didn't pick up on it, right? Like I guess it would kind of like show like there's been some creativity, because now what I'm doing is more surprising to the language model. Like presumably if it was like, and then we went to the doctor, and the doctor would, I don't know, you know, try to see like how much generic text is being kind of removed from your brain. It's weak still, but
Gotcha.
like that. I don't know.
Yeah.
I have to try it.
I'm actually curious why you chose named entities specifically rather than any entities. Because, for instance, in the example that we saw with temperature, like, one of the main identifications that low temperature meant less creativity and less variety was that they were all referring to hot or shed. Whereas with like high temperature, there were like many different like basement, I don't know. Well, there were other things as well. So like, why not use all entities rather than just named entities?
Yeah, that's also a good point. I guess with named entities, we are more confident that they're like really new. Like when you think about new characters, sure, like that's a new idea. But yeah, like when it comes to new entity, I guess it wasn't clear if we can completely disentangle whether that's just because of the relation between that entity and like whatever is written before. But yeah, it's all kind of fuzzy. So that might also work too.
With some sort, with some sort of like, I don't know, core reference resolution or something similar.
Yeah.
Like, well, so right, so if it was like, you know, it turns out that the doctor suggested using a lizard for her asthma, and then like the rest of the thing was about how you use a lizard and you swallow the lizard, and then the lizard comes back out of your stomach or something like that. Like presumably that's pretty creative, right? Like if you got that suggestion, then double down on it, that would be interesting. So that would be a case where you want to recognize that there's an entity there. That's like unusual or something.
Yeah, good call.
I guess another question that I had, probably not related to this, I don't know, now is a good time. Is related to the previous part. So I wanted to ask whether you actually looked at, so I think one of the questions was how language models and humans are interacting together, and like whether language model can follow human edits and stuff. So I wanted to ask, if you have any idea or measurement, like whether from like language models perspective, a text that has been edited by human is any different than the text that the language model outputs itself.
From language models perspective.
Like, yeah, basically like does the
like perplexity that
or classify it, or say was this text written by a language model or by me?
No, I mean like from the perspective of like the quality that the rest of the text that it will be outputting, or like does it help, does it hurt, or maybe there's no difference. So I guess I'm wondering about the effect of human edits.
Gotcha. Yeah, actually, that's something that I'll touch on the next part of the talk. We do, but it's not part of this second section. But yeah, we do see that some models do pick up from that kind of like learning signal from like human edits, and then be able to adapt over time. We see that from post editing the summaries generated by the machine, and using that as like in context learning examples. So yeah, it's all like part of the prompt, and then some models are able to generate like better summaries, like that's probably in the style of like the user edits. But yeah, here we don't look at that, but that's a great question. So yeah, I'll talk more about that in the next part of the topic. Alrighty, and the third finding, and the last finding of this part, is collaboration capabilities. And more specifically, we asked among the randomness of suggestions and prompts or individual user preferences, like what influences collaboration patterns the most? And when we aggregate, okay, so let me just show the plot. So we're looking at roughly the usage. We have a definition of the metric in the paper, but you can just think of it as like how much suggestions people use. And when you aggregate it over all the prompts and all the users, we actually don't see much difference based on just the randomness of suggestions. But when you
Can you explain your graph? What are the
Yes.
those 10 different prompts and what is low and what is high?
Yes, so that's about like this thing. So on the y-axis is the metric that we defined to measure like one type of collaboration pattern, which is usage. And on the x-axis is 10 different prompts used for creative writing. And the low and high are like the randomness of suggestions. So we see that for some prompts, it seemed like users have slightly more preference towards, like the suggestions with high randomness, and like for the other prompts, it's the other way around. So when you break it up by prompts, you do see some differences. But when you break it up by users, you see even more difference. So these are top 10 users who wrote like the most stories and essays. Some people wrote like over 50 stories. And you see that the user number 1 uses the suggestions regardless of the randomness like a lot, whereas the user number 2 relies less on these suggestions. So yeah, from this we conclude that probably the individual user preferences are the main factor that affects the collaboration pattern here.
Does randomness just mean a random word?
Randomness is
Oh, the temperature?
yes, the temperature and other decoding parameters that we tuned. Yeah. But of course, please take it with grain of salt because again, like these writing sessions were only 10 minutes long, and we looked at short stories and short essays. So this could be very different with also different user group as well.
What's the length of the story you consider? Like how many paragraphs and how quickly can you reach a conclusion? Was that evaluated?
So each story is, so on average it was like 400 words long, which could be maybe around 3 paragraphs or so.
Do you just like cut people off after 10 minutes?
No, they can write longer if they want, but crowd workers are incentivized to do the job as soon as possible.
So it had to be at least 10 minutes, right?
Exactly. So after 10 minutes, they could click like finish button, but most people finished in like roughly 11 minutes or something like that. Yeah. All right. So this analysis are, I would say, pretty like preliminary, and there are so many unanswered questions. And I would love to invite you to take a look at CoAuthor and use CoAuthor. And these are some of the questions we had. So the first one is about writers' behaviors and writing outcomes over time. I'm really curious whether we can observe novelty effect in CoAuthor because each writer interacted with GPT-3 multiple times. So it would be interesting to see how like their collaboration patterns change, and if they, learn to leverage these models in an interesting way, or if they get bored and just like don't use it at all after a while. And also in terms of writing outcomes, I'm curious whether these models might provide similar suggestions to all users, because we give people a prompt, which is usually a few sentences long in the beginning, and everyone like starts from that prompt. And we have some variations of prompts, but for those writing sessions started with the same prompt, like can we actually see if, like by using low randomness, like things become similar, or with high randomness, things become more diverse. And there are also questions about linguistic accommodation, how the user affects language models generation, which I think, I brought it up, and how also the opposite way, whether the language model influences the user's writing. And one participant actually reached out via email and said that the model kept generating really violent content, and like he tried really hard to steer it away from that, but then it was like really difficult because the model kept generating like violent outputs over and over. So you could imagine that it could kind of like excavate like pretty quickly. And lastly, I'm also curious if we can use these interaction traces to actually learn human behaviors and also train language models. For example, if you think about edits that participants made, like can we train an edit model and basically have that edit our story or essay? And yeah, can we train a model to emulate? So yeah, these are the open questions. And to summarize, we looked at interaction traces, which capture rich information in human language model interaction. And we built a large interaction data set. And with that, we hope to bridge the NLP and HCI communities by using it as a boundary object. And we publicly release the data and replay platform. And we are planning to open source the interface as well. All right, any question about this part or any thoughts or?
So the replay platform is basically the purpose going through like the entire IT session.
Sorry.
So the replay platform, is that like a user or like one session where they're actually going through the entire writing session, looking at the prompts?
Yeah.
That you have?
Yeah, exactly. It's the GIF that you saw. Yeah, so it will basically fetch the log from the server and then show you exactly what the user did, you know, including browsing the suggestions and so on.
Did you make any HCI additions to the service that benefited you, the human, as the researcher, for looking at what people were writing or being able to track what's going on, or is that mostly just done like post hoc? So, I mean, in terms of the software that you wrote, like, you know, obviously you want to make sure that the searchers have a good experience, but did you do anything to make sure that you had a good experience for analysis, for figuring out, you know, whether people are writing, for looking at the video playback, etc.?
I guess no. So I mostly worked with the raw log files, and I did want to improve the replay platform, at least like add, you know, like pause button and like have the navigation thing on the bottom so that like it's easy to browse. But yeah, I haven't had a chance to do that, but that would be nice. And we were also thinking about using replay as a like education tool for those who are interested in, you know, like learning creative writing and so on. And, you know, like they might be able to learn a lot from watching how expert like professional writers write. But yeah, we haven't had a chance to improve the platform yet, but yeah, hopefully I'll get back to that after this job search season. Yes.
I have a general question. I don't know whether I should wait till the end, but I'm just going to throw it out there.
Yes.
So a lot of the examples you showed were fictional text, you know, made by so, and then of course we
Right.
ChatGPT is very good at hallucinating. If you go more to kind of non-fictional text or even like, you know, Python programming, to the characteristics, are they at all comparable? Do you have anything kind of to report on that? Because it's quite possible that in the kind of fictional and hallucinating, you know, you have some good ideas.
Right.
And we use a lot. Things might shift a little bit for non-fiction text or applications like in Python programming. So I'm just totally curious.
Yes, that's a great question. Yeah, so in this project, we also looked at argumentative essay writing, which is, non-fictional. And we saw that for the three analysis, I think the first and third analysis about like fluency and collaboration pattern, we saw similar trends. It mostly depended on like users' preference, but then for the second one about ideation, I think overall we saw like much fewer new named entities suggested in the model outputs, and yeah, people were using way fewer of those like in the subsequent part of the text. So which makes sense because in creative writing, you can always take a new character and write off of it. But yeah, we do see some differences, but I guess, yeah, we didn't like delve in, like really deep to compare these two.
Yes.
Yeah, yes. But yeah, I guess overall we, so like in the free form, like survey responses from these workers, we do see a lot of complaints that we are all aware of, like nowadays, that like these models make up, like fake citations and stuff like that. So people were way more concerned about, yeah, that kind of aspects in argumentative essay writing for sure. But yeah, we didn't, yeah, like have any like quantitative, yeah, results for that. Yes.
The post edit split was always done auto-aggressively, or did you ever do like, could you rewind and say like, add a make a suggestion in the middle of these sentences?
Yeah, it was just left to right. Yeah, we could have used like fill in the blank type of model, but we just resorted to like GPT-3 because yeah, that was like what most people were interested in learning at that time. Yeah, we made a conscious decision of using GPT-3 like as is without even like fine tuning or prompt tuning, because there were a lot of work, well, maybe not a lot, but maybe a handful of work that fine tuned GPT-3 for like email writing specifically, or like, therapy session or so on. But then like those findings are hard to generalize because it really depends on, like how you adapt these models. So we wanted to have this as a like basically baseline that people can, resort to and look at to get a sense of like these language models capabilities. Right, so moving on to the last part of the talk, which is about evaluating interaction beyond writing. And this is the work with many amazing collaborators. And it's titled Evaluating Human Language Model Interaction. So we're going to look at interaction, but beyond like writing task and beyond textual input and output. So what do I mean by that? Let's take a look at example in question answering. So we have this question, like before Nixon resigned, how many believed he should be removed from office? And we have these 4 choices. Do people know the answer?
What does before mean? There's a lot of before.
Let's say right before he resigned. I don't know. But that's actually a question from MMLU. So yeah, the context is missing. Okay. I would assume most people, yes.
But it's yes.
Okay.
Yeah, I would also say D.
Cool. Yeah, we will see. So let's say that, yeah, you have that question and you want to answer it. And let's say that a user comes in and basically copies and pastes the question verbatim and queries the model. Then the model might give you an answer like this, like a majority of Americans believed, and this is actual output from TextDaVinci 3. And this is not that helpful because like a majority, it only rolls out like the choice 3. But then like what's important here is that the user can actually look at the model output and reformulate her query. So based on this output, like you can imagine like she can reformulate the query to be like what percentage of people believed Nixon should have been removed from office. And with that input, TextDaVinci 3 answers approximately 60% of Americans. So then the user can, choose the answer based on this output, which happens to be true. The answer is D. Yay! So notice that in the traditional benchmarking framework or practice, like these answers would be considered wrong because it doesn't belong to any of these 4 options. But you can see that the user, just by tweaking the prompt a little bit and then interpreting the model output, can actually get to the right choice. So here, like we care about interaction beyond just the raw model output. And maybe the more important questions to be asked here is something like this, like, was the user able to find the correct answer with the language model? And how many times did the user query the language model? So say that you're comparing multiple models, and with one model, you have to query like 5 times to find the information you want, but maybe with another model, you need to just query once. And did the language model generate anything offensive or misleading? Like if the model says, oh, wow, you don't even know that or something like that, then like you may not want to interact with the model anymore. So we also care about this. And we want to know, answer those questions because like currently language models are chosen based on their non-interactive performance. So we have a bunch of benchmarks and a lot of models, and we usually evaluate these models on these benchmarks. So let's say that we have 2 language models, and language model 1 performs better than 2 on a specific benchmark of your choice. And like right now, we're basically blindly hoping that, okay, if the model performs better than model 2 on that benchmark, then hopefully it will also be better for human language model interaction. But is that true? So as a community, like if we explicitly or implicitly optimize for non-interactive performance, like will this improve interactive performance? So that's the question we wanted to answer in this project. And our approach is called HALIE, Human AI Language-Based Interaction Evaluation. And we extend the standard non-interactive evaluation along these 3 dimensions. So the first dimension is evaluation targets. So in the standard benchmarking setting, you only look at like model output. But we argue that it is important to look at the process of human language model interaction. As we saw in CoAuthor, it contains rich information that can reveal a lot of different properties about the model. So we want to extend it to include process. And the second dimension is perspectives. So in standard setting, we don't have any users. So we just by default resort to third-party perspectives. So that may look like, okay, like this researcher thinks accuracy is most important on this domain. So we report accuracy. But in interactive settings, there are users who are like directly interacting with these models. And we want to account for their perspectives. So we include their opinions and their perceptions in the metrics, in addition to the metrics defined by third-party people. And lastly, we have evaluation criteria. And in non-interactive standard setting, we mostly care about quality, such as accuracy, robustness, like fluency. But then there is also preference. You can think about having 2 stories that are both like really high in terms of quality, but you may still prefer one over the other. So we want to capture that kind of like more subjective experience of people, and note that that can be done by both first-person perspectives, but also third-party perspectives. So we want to cover this entire space, like 2 by 2 by 2 cube. And to do so, we designed 5 tasks to capture a variety of interactions. So we considered social dialogue, question answering, crossword puzzles, text summarization, and metaphor generation. And to briefly introduce what each one is about, dialogue is pretty straightforward. You have a conversation with the model. Question answering, you query the model, get the output, and then you can reformulate your query if necessary, as we saw in the example. Crossword puzzle is a combination of these 2. So you have a crossword puzzle on the left-hand side, and on the right-hand side, you have a dialogue system. So you can query the model to brainstorm answers for these hints for the crossword puzzle. And then for text summarization, it's about post-editing. So the model first generates a summary for a given document, and the user edits the model-generated summary, and then that gets fed into the in-context learning prompt, and then like we repeat that process for 10 times and see how things change for I summary. And then for metaphor generation, it's more about brainstorming. So we ask the user to write as many metaphorical sentences as possible for a given metaphor, and the user can query the model, get suggestion, edit it, and then like submit metaphorical sentences whenever they think it's good enough. So it covers like both open-ended and goal-oriented tasks, and then it covers the common usages of language models reported by OpenAI. So these are the screenshots of the systems. Feel free to check out the detail in the paper. And with that, we collected 1,000 interaction traces across 5 tasks. And we designed like 47 metrics covering all dimensions. And we compared these 4 models. In the top, I'll mostly compare Text DaVinci to Text Babbage. But yeah, this was to evaluate the effect of size, effect of instruction, and effect of maker. And Text DaVinci is like roughly 100 times bigger than Text Babbage.
What's Jumbo?
Oh, that's AI21's Jurassic 1 Jumbo. It's similar to DaVinci. AI21 Labs. Yeah, they're the people who made WordTune. Okay. Yeah.
So all what's happening.
Yeah. There are so many players in the word. Okay, so 6 minutes. Let's use HALIE to answer the research question we had earlier on. Like whether the non-interactive performance translated to interactive performance. And the short answer is yes, it's mostly true, but there are some notable exceptions. So I will share these exceptions briefly. So the first one is about output versus process. And can we just optimize for non-interactive performance? And the answer is maybe no. So here we see that, so this result is based on the question answering task, especially for nutrition category. And we see that the Text DaVinci performs way better than Text Babbage as a zero-shot model. But then when you deploy it to support humans in finding the answers to the questions, we actually see similar performance. So a model with worse zero-shot performance can result in like comparable human language model performance. And you may notice that the accuracy for Text DaVinci actually dropped, like when it's interacting with humans. And one hypothesis for that is that users may not know how to prompt language models effectively. So earlier on, I asked you, what do you think is the answer? And let's say that you knew that maybe it's D, and you wanted to use this model to verify your answer, which is the kind of usage we see in the people's interaction. And let's say that the user asked, like, did 57% of people believe as a way to verify? Then actually the same model, Text DaVinci 3, like contradicts itself and say, no, like 57% of people did not believe, and it's actually 29%, which could lead to a wrong answer. And the second finding is about first person versus third party. So can we evaluate language models solely based on user ratings? So if the user interacting with these 2 models say that, okay, this model is more helpful than the other model, then can we safely conclude that the Text DaVinci is actually better? And the answer is not always. Here it's a result crossword puzzle. And we see that users may perceive language models to be more helpful than they actually are. So here you see that the actual accuracy of crossword puzzles is higher for text Babbage and human. And one hypothesis we have is that text Da Vinci generates really fluent but also confident outputs, which probably like made the participants believe that these models are helpful, but actually it was like misleading. All right, so last finding is about quality versus preference. So can we simply take a majority vote on a set of metrics? So for instance, when we evaluate a dialogue system, we have like various metrics that we care about, such as fluency, sensibleness, humanness, et cetera, et cetera. And let's say that text Da Vinci performs better than Da Vinci on basically all of the metrics except for specificity, which we observed in our experiment. And if you only look at this like left-hand side, then you may conclude, okay, then text Da Vinci is better. But then when you ask people, would you prefer to like interact with this model, or would you be inclined to continue chatting with this model, then actually it's quite similar. And the only metric that Da Vinci outperforms text Da Vinci is specificity, which is about how specific like the model's response is to the user, what user has said before. So you can imagine like the user saying, oh, I have a cat. Then like we actually see that the text Da Vinci generating, oh, what's your cat name? And variation of that like 5 to 10 times, like with different seeds and with different sampling. Whereas Da Vinci will generate like more diverse outputs. And so that might be also contributing to that. So yeah, this illustrates that like the user preference needs to be taken into account when you choose the model to deploy for interactive usage. So that was the third part of the talk where I introduced the new evaluation framework called HALIE, and we saw 3 notable exceptions. And I guess we're out of time. But yeah, just to bring your attention back to these quotes. Yeah, I'm curious what you think. Do you think like CoAuthor kind of illustrates the way that people use these language models as a, you know, something to write down the words and they're basically playing the role of editor? Or is it giving some sort of inspiration to the users and making them more creative and like go outside of their usual comfort zone, or like fixed set of vocabulary that you always use? Or is it actually misleading or like restricting you in some ways by writing down something on the page or showing some sort of misinformation? So yeah, a lot to think about. But yeah, that's my talk, and thank you so much.
Thanks so much for the great talk. Since we're at time and we had a lot of questions throughout the talk, I don't think we'll take questions now, unless there is a question from the virtual audience. I'll just give them a minute to ask any questions. But if not, yeah, I think we can conclude the talk today. Thank you so much for coming to the talk. Just a quick announcement. Next week we'll have Ruichi Zhong from UC Berkeley. I believe she's a friend of Chin Yuan. His talk is going to be titled "Getting AIs to Do Things I Can't." So stay tuned for that. All right, thank you so much.